All right, last lesson in this unit, we want to talk about systems of quadratic inequalities. So if I have a system of inequalities that contains quadratics, I might have something that looks like this. Y is less than or equal to negative x squared minus 4x plus 3. And y is greater than x squared plus 3. This is my system of quadratic inequalities. You're going to find that this works very similar to systems of equations and inequalities we've done before. The only difference is this time we have quadratics. And some of the same things hold. If I have got a less than or equal to or greater than or equal to sign, I need a solid line on my quadratic. If I've got a less than or greater than, I need a dotted line for my boundary line. So this one would be solid. This one would be dotted when I drew in my boundary line. I also am going to do some things like find a test value. I'm going to shade the true region. So let's start off by graphing these two quadratics. Well, if I graph this one, y is less than or equal to negative x squared minus 4x plus 3. And you can use whatever method you want to use to find the graph of your quadratic. But let's set us up here a graph. And we're going to mark these off in ones, 1, 2, 3. And mark these off in ones, 1, 2, 3. And if I choose some points, if I find my vertex, if I then find a few more values for my function, I will find that this particular quadratic has a vertex that occurs at negative 2 on the x-axis and 1, 2, 3, 4, 5, 6, 7 on the y-axis. So here's my vertex. It has a y-intercept of 3, so we can reflect that across the axis of symmetry, and I'm over here at 3. It's got a standard shape to it, so down 1 and over 1, down 1 and over 1, and I could go over 3 and down 9 if I want, which gives me these 2 points. So let's graph this, and I get a graph that looks like this. Well, what is the next decision you need to make? You need to decide which part of this do I want to shade. And to do that, we're going to use a test value. Well, you will quickly learn that since this says less than, I already know which part of this is less than the other. It's going to be this inside part, but let's look at it in terms of using a test value. If I put 0, 0 into this equation, I get 0 is less than or equal to negative 0 squared minus 4 times 0 plus 3. 0 is less than or equal to 3. Is that a true statement? It is, which means we're going to shade the true region. And a little different from what we've seen with lines, that true region, instead of going to be being above or below a line, it's going to be inside or outside of our parabola. So let's see if I can change the color of my ink here. I have a little bit of issue with doing that. Can turn my ink red. So if I shade the inside of this quadratic, look what I get. I get this part right in here. All of this. Why are we not drawing here? There we go. I'm not pushing hard enough. So I'm going to shade all of this stuff inside of my quadratic. All right, doesn't make a great picture here, shading with my pens, but you get the picture. We're shading everything inside of my parabola. So I know that part is part of my solution region. So, well, what about the other quadratic? Well, the other quadratic, y is greater than x squared plus 3. We have a standard quadratic that's shifted, that has a vertical translation up 3. which means we have a vertex right here at 0, 3. And then over 1 and up 1, over 2 and up 4, over 3 and up 9, and we can graph our parabola. But let's pay attention here. Look what we have here. This is a greater than sign. There's no equal to sign included in that. So this needs to be a dotted line. So I'm going to make this a dotted line as I draw in my parabola. My boundary is going to be a curve that is dotted instead of being a curve that is solid. So there is my second parabola. Well, once I do that, what am I going to do to test it? Well, the same thing I did before. I'm going to choose this test value of, and for some reason I didn't write a minute ago. Let's write this down. 0, 0. So I'm going to put in my 0, 0. Now notice, 0, 0 this time is outside of my parabola. So I want to know whether or not it's true or false. 0 is greater than 0 squared plus 3. Well, 0, 0 plugged in here gives me a false value. So I don't want to shade the part that includes 0, 0. I don't want to shade this part outside of this parabola. It was false. I want to shade the true region. So we're going to shade the part that's on the inside. So let's turn this blue and shade the inside of my parabola. Alright, so I have shaded the inside of my parabola. Everything that's on the inside. Well, let's think back. What did we do when we had a system of linear inequalities? The solution to your system of linear inequalities was the part you shaded both times. My solution is from this point of intersection right here to this point of intersection right here. It's up to this boundary line, and then it's everything inside of the region. This part right through here is that I shaded both times is the solution to my system of inequalities. So, just to summarize, you're going to graph your boundary lines, and you're going to do that using any method that we have previously learned. You're going to decide if those boundary lines are solid or dotted. You're going to choose a test value. You're going to shade the true region, which will be either inside or outside of the parabola, and then the part you shade both times is the solution to your system of quadratic inequalities.